Alright, today I'll talk about the problem buy low, buy lower. So in this problem, we will use dynamic programming to find the longest decreasing subsequence. And the difficult part about this is that we have to count how many distinct subsequences there are for the longest decreasing sequence. So we cannot have any overlaps that basically have the same sequence even though there are different indexes. And here you have there might be a lot of ways to count the subsequence. So you have to use a big number structure, and you have to do that program that yourself out here. So this is my big number structure. I will first give it a size and a digit and a digit array. I will set the maximum digit to 100. So we can assume that the problem has a maximum number of less than 10 to the power of 100. And here we'll have two ways of initializing this. The first way, we'll just set everything to 0 and give it a size of 1, so there will be just one digit and that is a 0. Or the other way is you can set also basically the same thing. You can set everything to 0, give it a size of 1, but here the first digit will be s. And here's the add operation. To add a and b, we will first create another big number and just call that sum, and then we'll get the length of the maximum. We'll get the maximum length for these two, so then we can loop all the way to the end and then add all the digits. And then here is basically how you will add two big numbers on a paper. So first you look at each digit, you add those two digits together along with the digit that you carried over from the last digit, and so you have to check this current digit. If it's greater than or equal to 10, then we will take away 10 from this digit, and also we will make sure that we will carry that 10 over to the next digit, and we just set the current digit at, so we'll set the current ith digit to this temporary sum minus 10. And otherwise, if this temporary sum isn't greater than or equal to 10, we can just set this digit to whatever it is. And then here, after we finish adding all of it, we will set the size to the maximum length of these two digits. And also we have to check if we incremented anything. So we have to carry over this. And if we do have something to carry, then we will increase the size by 1 and set the last digit to 1. So this basically stores the number in the reverse order. When we print it out, we'll just print it out in the other order. And finally, we'll just assign a to the sum. So we'll assign a to whatever a plus b is. And then here's basically our main code. We will use dynamic programming to find this, as I said. So first, this part is the normal part of finding the length of the longest decreasing sequence. It's so first you will loop to every of this digit, and then you're going to check everything before it. If there is a price before it that is greater than the current price, this means that this price is basically decreasing if we select the previous price. And so we can set our current DPI, which is our current current price, to the maximum of our current DP, or the length of this current of this previous price j plus 1. So or plus 1, because now if we add another digit to this subsequence, we are going to get one more in our length. And then finally here we'll compare our maximum length with this current DPI. If DPI is greater, we'll set it to our maximum length. And then here is the part where we make sure we don't have any overlaps, and also count the number of distinct permutations for this subsequence. And so first we will just basically do the same thing, also loop from 0 to n, so loop through each of the price, and we will check if our current DPI is equal to 1. So if DPI is equal to 1, this means that our only our maximum decreasing sequence for this current index I will only be itself. And if that's the case, then we'll just set our amount of ways that we can get to this 1. And so this is why we have to use the initialization here. We will just set this big number to 1. And otherwise, we will create this, I will clear out this visited map. So I use this map to keep track of all the things that, all the prices that we've already visited, so we don't visit them again. And we just go into decreasing index. So we start at I-1, go all the way to 0. And this way we will get the maximum dpj. So here we will first check if we've already visited this price j. If we already visited this price j, then we can continue into the next price, continue to the previous price. And then otherwise, if we didn't visit this yet, and this price is greater, this price j is greater than price I, so this means that this j was smaller than I, but the price is greater than price I. So this means that I is smaller. The current price right now is smaller than the previous price, and so that means we can have a decreasing subsequence. And we also need to check if our dpi is equal to dpj plus 1. So this is basically what we did here. So we have to check if we assigned I to what this j is. So if we actually did assign I to this dpj plus 1, then we will set this visited price j to 1. This means that we've visited this price and we don't need to visit that again later on in this loop. And also we will increase our count I by this count j. So here we'll just keep on looping through this until we've visited all the distinct prices, and we will add every of these count. So we'll add the number of ways to form for these previous counts into our current count. And finally, so this will go on for all of the indices. And after this, we will print this out in one last loop. So we'll get our answer. Our answer is just a count of all of those, of all of the prices. But we also have to make sure that we didn't visit. Also, we have to make sure that the prices are distinct. So we have to make sure that we don't visit any of the prices twice. And so we still have this visited map here. And we also check if the dpi is equal to our maximum length of the decreasing sequence. If it is, then we will add our answer by this count I. And finally, we will just print out the answer, but we cannot just print it out because we don't have any print operations here for this big number. So we'll just use a loop to go starting at the size -1 all the way to 0. So as I said, the digits are stored in the reverse order, so we'll have to print it out in the reverse order as well. So you'll just print out everything, and also at first here you have to print out the maximum length, and then after you print out the answer, you can just print out a new line and stop the program.